So today what we're going to do, we're going to name acids. And we name acids slightly different than we do ionic compounds. A couple of things just to kind of make sure we're on the same page is that acids involve H plus. So hydrogen is considered to have a positive one charge. It's actually H plus in aqueous solutions. There's two types we're going to deal with. The first one is a binary acid. So binary means two. And basically that means H plus plus a nonmetal. Now, one thing about it is that there's no oxygen for these binary acids. One that we're familiar with is HCl. So basically, that's H plus and Cl negative. So chlorine or chloride has a negative one charge, hydrogen has a positive one charge, and it's a 1-to-1 ratio. This one is hydrochloric acid, which we're familiar with. The thing that stays the same is the hydroic acid. So all these binary acid, it'll just be hydrogen plus one nonmetal. It'll be hydroic acid. Another one is HF. That's going to be hydrofluoric acid. Again, remember, it's always H plus F negative, even though we don't write the charges there. That's why it's a 1-to-1 ratio. Some other ones, hydrobromic, hydroiodic, hydrosulfuric acid. The reason this is H2S is that, remember, hydrogen is positive 1, sulfide is negative 2, so we just reverse the 2 and the 1. So again, these are binary acids. The ones we use the most in the lab are hydrochloric. Hydrofluoric, not so much because that's a very dangerous acid, but hydrochloric acid you see in the lab all the time. The second type we're going to look at are oxyacids. These contain oxygen. Couple of things. These come from polyatomic ions. So I gave you a list of polyatomic ions to learn. So these are oxyacids that contain polyatomic ions. The first type of oxyacid is going to be from the polyatomic ions that end in ATE. So again, depends on the end of the polyatomic ion is how we name the acid. This one right here is a sulfate ion, and it's an ATE. Again, it's an oxy because it contains oxygen. Another one is nitrate. So all the ones we're going to name come from polyatomic ions that end in ATE. Again, they all contain oxygen. And then we have acetate, phosphate, carbonate, and perchlorate. So again, these are polyatomics in ATE, and these are going to make up the oxyacids. The first one, and again, I should say they all end in ic acid, by the way. The first one that's probably the most common is H2SO4. This is sulfuric acid. So the other one was hydroic acid. This is just ic acid. I noticed that it's H2 because remember, hydrogen is positive 1, sulfate is negative 2, so we just reverse the 2 and the 1. So it's high at sulfuric acid, H2SO4. Another one is HNO3. So in this case, hydrogen is H+. The nitrate, if you look at that, is NO3 negative. So it's just a 1-to-1 ratio. This one is going to be nitric acid. The other ones, acetic acid, phosphoric acid, carbonic, and perchloric acid. This is the perchlorate ion, by the way. It's a 1-to-1 ratio. It's perchloric acid, but they all end in ic acid, and they come from the ATE. That's the main thing. The last type, and this one only has a couple of these, are oxyacids that end in ITE. The two most common are going to be the sulfite ion and the nitrite ion. SO4 2 negative, that's sulfate. If I have one less oxygen, it's sulfite. Same thing. Nitrite, it came from nitrate. The charges don't change. So even though I have one less oxygen, charge stays the same, but I go from 8 to ite. These are going to end in us acid. So for instance, H2SO3, sulfurous acid, and then the last one, HNO2, nitrous acid. So again, these two are a little bit less common than something like sulfuric acid, nitric acid, but you still see these from time to time.